Hello students, good morning everyone. Welcome back to the online class. Today, let us learn about stack and queues. What are the basic concepts of stack and queues? So in this class, today we will learn about what is the stack, what are the instructions of stacks and queues. Okay, so in the last class or in the last video, we have seen that or we are discussing about programming languages. So in that high level language, low level language and machine level language, and also we are discussing about features of all the languages. Okay, so today we will move on to the stack. So first of all, stack is a group of memory location. Stack is the group of memory location. Means what? You have to read or you have to write. Second one, it is a linear data structure. So linearly you have to take the elements, where insertion of the elements or deletion of the elements is done from only one side or a end, which is called as top of the stack. So take some elements, arrange in a proper way. Okay, so once you are going to arrange that one, you have to insert the elements or you have to remove that elements. Deletion means what? You have to remove. Okay, so third one, stack are also called as LIPO, that is the last in first out, or FILO, first in last out. It is also called as a push down list. It is only used for storing and retrieving but not for data transfer. So it is only used for storing and retrieving but not for data transfer. So it is for you have to store and you have to retrieve but not for data transfer. Okay, so next, so this is one of the example. Already I told that you have to take plates, you have to arrange in one increasing order. So in that increasing order, whatever that top of the plate is there or top of the stack is there, you have to remove one by one. You have to remove. So that is the top of the stack. Next, stack. So there are two operations. One is the push, another one is the pop, and third one you can say HTHL. Fourth one you can say SPHL. So we will discuss the push. Push operation said that push is having 2 byte of data into stack and pop is having 2 byte of data from stack. So in push, you have to take the data and store into that stack pointer. Means what? You have to insert and store into that stack pointer, that of that memory location. 2 byte means what? Take some registers examples. Okay, so HL you can take, or AB or CD, or you can DA, you can take that registers. So in HL, 2 byte means what? You are having total 16 bits. So H is one 8 bit and L is what? One 8 bit. So 8 plus 8 is having what? Total 16 bits of data you can store into what? Stack pointer. So in the same way in pop, 2 byte of the data from stack. So you have to delete or you have to remove from that stack pointer 2 byte. Same way you can take CD. So C is the 8 bit, D is the 8 bit, 8 plus 8 total 16 bits of data you can remove from that stack pointer. HTHL, so that stands for exchange top of stack with HL. Exchange top of stack with HL. SPHL, move contents of HL into stack. So what is that SPHL? Whatever that data contents are there, you can move directly towards the what? HL2 of that memory location of that register. So exchange is top of the stack with HL means what? So you are having what? Two registers. One is for what? HL, and the other one is for what? CD. And you take two stacks. In one stack of the memory location you can say HL, and the stack of the memory location you can say CD. Okay, so you can exchange that one. HL will be exchanged with what? That CD. So that is the HTHL, exchange of top of the stack with HL. So again you are having what? Input output operations in. So whatever your stack information or stack will be start from initiate input operation. So whenever if you want to operate, So you need what? Input. So that purpose stack will be always start from what? Initiate input operation. Example, in 8-bit data, A is your what? One opcode. Okay. So in that you are having what? 8-bit data with respect to memory locations. So for example, in you are having what? FFH is your what? Storage data. Okay. So in that A, you can move or you can write FFH to the what? That A. In the same way out. So after the execution, you can take the initiate the output operation. Once you are going to execute that program, you can remove that from what? That out instruction. That is the out 8-bit data. So 8-bit data should be what? In A. So EEH and A in EEH. This is the one data I am going to considering with respect to this data I am going to execute in that program. Okay. So in that memory locations. So next we will move on to the stack instructions. So in that first one, LXI-SP, that is a stack pointer. So this instruction will define beginning of stack. So whenever if you want to write the program or if you want to start your stack process, you need what? Stack pointer. So that purpose LXI is the first will define the beginning of the stack. It is used to create or initialize the stack pointer register. It is used to create or initialize the stack pointer register. For example, you can take LXI-SP, 16-bit address. LXI-SP, 16-bit address. You can take on stack pointer. First initialize the address, that is the 16-bit. So this 16-bit will be located in the stack pointer of the memory locations. Okay. So this is the first point of stack pointer with respect to what? LXI-SP. So first you have to initialize or you have to create to the what? That stack pointer of that register. Second one, push RP. Second one is the push RP. So what is that push RP? It is the second instructions of that stack. Pre-decimal. RP stands for register pair. So pre-decimal. So this instruction copies contents of RP into the stack. Means what? For every push, you are having what? You have to do the first decrement of the stack pointer plus push of that RP. And again you have to decrement of that stack pointer plus push of that RL. So RH and RL, push of that RH and push of that RL stands for high and low bits. Okay. So for example, whenever you are going to do this instruction or performance of that these functions, so every time first you have to decrement that stack pointer, then you have to do the push operation with respect to high and low, RH and RL. Okay, example, you can take LXI SP, FFFH. So this is one locations. You have taken the consider this location FFFF. So again you can write push B and push D. So you can take the some addresses or some names with respect to what in BC register pair. You can take 10 A to H. In D you can take AF 1 to H. Okay, these are the values given by BC and E. Consider this or assume you have to this values. Assume this values. So take one stack. First, in first step, you have to write that memory location of that address FFFF. And in the second, so in push B, so whatever that push B, so in that whatever that push B is there, so whatever that BC of that address of that values are there, so you have to first write that value of low bit, so that is the 10, and remaining that high bit is there. So next means what? A2 FFD or FFE. FFE first means what? You have to first decrementing that push BC or push B, decrementing that stack pointer. Then you are writing the push of that writing that push of that high address. High address. So that high address you are writing first 10. First you are decrementing whatever that FFF is there. You can write decrement of that stack pointer FFFE. Okay, so write the value of push of that high bit, that is the 10. So then again you have to decrement of that stack pointer FFFD. Then you can write the low bit of that push, that is the A2. Okay, so this is the clear for what? Push B. So next same way you can take the push D. So for register that D you can consider assume the value AF1 to H. So same way you can first decrement the stack pointer. Decrement the stack pointer. So what is the decrement? Again FFFC. So you are having first decrement is FFFD. First is the FFFE, FFFD, then FFFC. So then write the push of high bit, that is the AF. Then again you can decrement the stack pointer FFFFB. Then you can write the value of that low bit, that is the 12. So like this stack operation will be performed by using push RP, that is the pre-decimal. First you have to decrement of that stack pointer, then you can write the push operation of that memory location with respect to high bit as well as what low bit by using RH and RL. So next we will discuss pop instructions. So what is that pop? So pop RP, post increment. What is that pop? It is a post increment. What do you mean by this one? First, it is used for retrieving the elements stored in the stack. Retrieving elements stored in the stack. Okay, so for every pop, get 1 byte from stack to RPL plus increment that stack pointer. So every time you have to remove 1 byte of the stack to the RPL low bit. So then you have to increment that stack pointer. It is a totally reverse operation of whatever push. So second time you can take get 1 byte from the stack plus to the RPH plus increment to the that stack pointer. Okay, so in push you are performing first decrement of stack pointer plus push RH and RL, and here you are using get 1 byte of from the stack to RPL plus increment of stack, and next one is the again get 1 byte of stack to RPH plus increment of that stack pointer. So consider one example. By using this example you can take one stack pointer. Okay, so in that stack pointer you can write the value write the addresses of that memory locations of that stack, that is the FF14, FF13, FF12, FF1. Like this will get the increment, means what? FF11, FF12, FF13, FF14. Like this increment you are doing here. So first here in pop you can use it here accumulator and flag register. So in accumulator you can store some value and in flag you can store some value. So first consider you are having what? First value is the 30 and 3 up. Okay, so 30 and 3 up. So in that you can take HL is one register. So here again in 1 byte, in H you have to write some value and in L you have to write some value. So whatever that 3F is there, it will given to the L, that is the low bit, and in H you have to write or stored into what? Your 30. So you can give the locations in increment. First get 1 byte and then increment. I mean like that. 3F you can write FF11, then 30 value, put the value of that 30. Then you can increment FF12. So like that same only you can use 50 and 4F. Okay, so first you have to write the 4F in flag and 50 in accumulator value in the stored. So FF13 and FF14. Same way you can get 1 byte from stack to RPH plus increment in the stack pointer. So like that you have to increment FF13, FF14. So this is also one of the example with respect to what? Push RP, that is a pop RP, that is the post increment. It's a totally reverse operation of push. So next we will discuss queue. What is the queue? Generally queue is comes under in data structure, stack also comes under in data structure. So it is a first of all PPO, it is the first in first out. It is a linear list of elements. It is the linear list of elements. Insertion at one end and deletion at another end or other end. So you have to insert at one end and you have to remove from other end. So take one example. I will take one array with respect to that array, I will write the elements 0, 1, 2, 3, 4, 5, 6. Okay, so at the right side you are having what? Rear end. At the front side you are having what? Front end. So I will allocate my front end and rear end. So what it will says, insertion from rear end, insertion from rear end, and deletion from other end, or from end, sorry, other end. Means what? So an example, I will take one array. So in that array, I will allocate my memory location 0, 1, 2, 3, 4, 5, 6. Okay. So in queue, first in, first out. Okay. So you have to insert. Through that rear end only you can insert. Okay. So not like that in front end. Okay. So first I will consider some values with respect to that memory location. 10, 11, 12 and 13 is my values. So in that array or in that elements, I will write that location to the that values. So first I will write or insert 10. Okay, so that is my first queue by using rear end. So that is the value of 10 in that first location. So once I will take that, next I will take my 11. So but 11 will be entered into what? That 10. So 10 will be removed and it will shifted towards the what? Next location. So then I will write here 10. 10 is the second location in that fifth position, and 11 is the first position. In the same way, I will take 12th value. So that 12th value again I will remove that 11 and will insert into what? 12. Okay, and this 12 will be this 11 will be shifted towards the second location, and this 10 will be shifted to the third position. So like that, 10, 11 and 12 is my what? Values in that queue. So same way I will take my 13 value, again insert into what? First rear end. So I will remove that 12, I will insert into what? 13. So once I am going to insert that 13 value into the what? That 12, what will happen? So that 12 will be shifted towards the what? In the place of 11. 11 will be in the place of 10 and 10 will be in the place of next shift. It will shift towards the what? Again the left direction. So like that you can fill the values by using queue. So again this is a queue is the list of elements, or it is the first in, first out. So in queue operation we will discuss in the next class, or again we will discuss in the what? Your next class, queue operations. So in that queue operation we will discuss all the operations which are related to queues, and also we will discuss subroutines. So what is the meaning of subroutines, and how it will operated in computer architecture. Okay, so this is the brief introductions which are related to what? Stack and queues. Okay, so in the next class we will discuss the related to queue operations and subroutine. So thank you. I hope you people will understand this concept. Thank you.